My name is Eric Chamois. Thank you for joining me in this ADMET Predictor interactive tutorial dedicated to the transporters module. For reference, I am using version 12 of ADMET Predictor, which at the time of this recording is the most recent release of the software. So our topic for today will focus on transporters and how you can make use of transporter models as part of a study. So we're going to start with a few slides and then quickly transition to the software. So the first question is really why are we even interested in transporters in the first place? And the fact of the matter is that there are many important effects that can result from the interaction with transporters. For example, certain compounds can act as inhibitors of transporters. They can also act as inducers through a phenomenon known as induction for PGP or for other transporters. And these kinds of interactions can contribute significantly to the variability of drug concentration and response. So the interaction with transporters can result in increased exposure in some cases, and in other cases, in decreased exposure to a compound. So in the case of increased exposure, you may see some increased toxicity, and in the case of decreased exposure, it just may be lesser efficacy of the compound under study. So for these reasons, it's very important that we get a good handle on these transporters and see if we can model them appropriately. So the second question is, well, where do we find these transporters? And most of the transporters, at least those of interest for drug-drug interactions, are expressed at epithelial barriers, for example, in intestinal enterocytes, hepatocytes, and in the kidney proximal tubule cells. So, for example, in intestinal epithelia, you might find PGP transporters, BCRP, they're both efflux transporters. In hepatocytes, you might find OATP1B1 and OATP1B3 and OCT1. In kidney proximal tubules, you might find OAT1, OAT3, or OCT2. Note that the transporters which are highlighted in red are those that we have studied and incorporated models for in ADMET Predictor. Also note that there are many other transporters for which we do not yet have a model. And the biggest challenge that we have in modeling these receptors is really number one, finding data, and also finding data which quality is sufficient to allow a robust model construction. So, as I mentioned, these transporters and transporter-related studies are very important, and most regulatory agencies recommend that transporter-mediated drug-drug interaction studies be performed, again, as part of drug studies, drug development studies. So the next question is, well, which ones do we cover in ADMET Predictor? So there are a number of transporters, actually 24, that we provide a total of 24 models in version 12 of ADMET Predictor. There are 8 substrate, non-substrate classification models. These are the ones that you see here in this row. There are 9 inhibitor, non-inhibitor classification models. These are the ones that you find in this third row. There is 1 inhibition IC50 model, that's for BSEP, and there are 6 km regression models for these transporters. Notice that, as I mentioned earlier, we are limited in what we can model primarily just on the availability of data. For example, it's very difficult to obtain, KM data for efflux transporters like PJP and BCRP. So again, this is what we have available right now in ADMET Predictor. So we're going to jump in the software and show you how these work. We're going to go through an example of how to use models from the transporters module in ADMET Predictor. So let's get started. I opened up an ADMET Predictor session here, and we're going to load a data set, which is a subset of the enamine discovery library. The original one has, I think, about 10,000 compounds in it. I just took this subset of 2,000 just as an exemplification for going through this little study here. So the first thing we're going to do is we're going to calculate properties for transporters. And the way you do this under data, you go to calculate ADMET properties, or you can also use this ADMET properties icon over here. And if you license the transporters module, then this option will be available to you. Of course, there are other properties which you could be interested in calculating as well. For now, we're just going to focus on transporters. So we're going to leave the other ones out. So you can select all of them by default. You would have all of them, but you can also customize the ones that you would like to see calculated. So for example, if there are certain ones you want to omit, then you could select them, or you just include them all. We're actually going to calculate all of them right now. So let's calculate our properties. This is a pretty fast process. And very quickly, the software comes back with predicted values for our transporters. Notice that if you had calculated other properties and you only wanted to see transporters, you have a transporter tab that's available to you here. This way, the transporter models do not get buried in an otherwise pretty large amount of data. So notice here that most of the models are classification models with a certain predicted outcome. So they're classification models. So it's going to say yes, no. For example, for BCRP here, we have the state of the prediction, which is yes or no, and then the confidence in the prediction, which is in parentheses here. If you hover over the top of the column, you get a tooltip, which again gives you a little bit of information about the endpoint. So these classification models, they are ANNE, otherwise known as artificial neural network ensemble models, with the confidence that you have in parentheses here being related to the consensus within the ensemble. So there are typically 33 members of the ensemble, with each one getting a vote. So if the ensemble votes with a large consensus, then the confidence is high, like for example here with 98%. But if there is a lower consensus divergence between the votes, then the confidence is going to be lower, like for example here, it's only 60%. Note that anything less than 60% is questionable, and in these instances, it may be preferable to proceed to experimentation for that endpoint. So in this plot here, you can visualize, for example, the different bins. So, which compounds would be PGP substrates or not. So you can, for example, select this and get an idea of the number of compounds in each bin. That's pretty simple. And you can also obtain a chart relating to the confidence in the prediction. So the confidence here is what is in conf colon. So if we want to get the confidence, for example, for the PGP inhibitor model and the PGP substrate model, then we just select these. So we've got conf for this one and PGP substrate, and just say OK. And so this gives you kind of a map of where the predictions of low and high confidence are for these two models. So the preferred area clearly is here in the upper right corner, where we have a high confidence in both of the models. Again, if we're specifically interested in the PGP substrate and PGP inhibitor models. Okay, so one of the things I'd like to show you is how, for example, you would be out of this list be able to select the compounds which are non-substrate and non-inhibitor for PGP with a high confidence. Okay, so the way you would do this is it's kind of an advanced kind of selection. So under Edit, you're going to see this option to query by substructure or structure substructure, but also by property. And we're going to clear this. I'm going to show you how this is done. The way you do this is using what's called the query wizard. So if you click on query wizard, you will see your list of properties or attributes of properties over here. And the first thing you might want to select here is the PGP. So PGP inhibitor is here. So you can select this one, double click on it, and then say that you would like the status to be no. Okay, so we want a non-inhibitor of PGP. Okay, and we want a non-substrate of PGP. So we'll double click on this again and say that we would like the status to be no. Just type no, NO. Okay. Now we want to put a high confidence for both of them. So we're going to use our AND operator once again. So we're just going to say AND. We want the confidence to be high. So confidence in PGP inhibitor in the prediction is high. So say we would like to set that more than 90%. Okay. And the last one, we're going to do another AND, and PGP substrate this time, we're going to set that also with a confidence of more than 90%. Okay. So this is our advanced query. And if we do this, then just click OK. The query is established, and say OK as well. So again, we had 2,000 compounds. The ones that are highlighted are the ones that meet these requirements. Under View, if you only want to view these, you'd say View, go under Hide, Unhide, and you would, for example, hide the unselected compounds. And you're going to see that there are actually 15 compounds in this data set of 2,000 that pass this criteria. Okay, so we can go back to View and unhide all. And if we want to see both distributions, then we can just do this here and also map here. That should map to that higher quadrant over there, as we said. So there are non-PGP substrates. There would also be non-inhibitors as well. So and again, you can visualize both. Go back to the hide unselected, and you can view that they're all non-inhibitors, and non-substrate with a high level of confidence. So again, that's the way that you can achieve these kinds of selections. So one thing I wanted to mention, let's just go back to the full view. One thing I wanted to mention is the use of the BCEP model. There are there are actually two models. So BCEP stands for Bile Salt Export Pump. The model predicts whether or not a compound is likely to inhibit toryl chlorate, which is the substrate transport by BCEP. So again, there are two BCEP models. There's a classification model and a regression model. Okay. And what I want to say is that these two can and should be used in tandem. So the BCEP classification model predicts whether or not a compound will inhibit toryl chlorate transport by BCEP with an IC50 less than 60 micromolar. So 60 micromolar is the threshold for the classification. And there are 615 compounds in the training set. The sensitivity and specificity are both in the 90% range, which is actually quite good. Okay. The companion BCEP IC50 model, which is right here. So if you hover over that top, it'll show you what these are. So again, this one is the classification model. This one is the regression model. The companion BCEP IC50 regression model was created using 155 compounds with IC50 values less than 133 micromolar, and that was selected based on range. So what's important here is that these classification and regression models are intended to work in tandem with each other. So if the classification model predicts no, then you're in the clear. You're okay. If it predicts yes, then it makes sense to look on the column on the right, to see what the IC50 model predicts, and if it's above or below the threshold that you deem acceptable. So there's actually, if you are a user of the toxicity module, there's a similar situation with the herd model for cardiotoxicity, where we also have two models that work in tandem with each other. So again, I hope that gives you a pretty good sense of how you can work with transporters. And if you have any questions, then definitely contact us for, again, any further questions you might have about these models. Thank you so much, and you have a great day.